Hello again. This is Math 2231 remote delivery for April 21, 2020, and the topic is U substitution. And I encourage you to pause the videos as you go through to make your understanding. As often I do, I want to applaud your efforts in hanging in there. This is unprecedented circumstances, and what you're accomplishing is extraordinary. Your educational goals need not be deferred. Let me begin by making an analogy from your study of algebra. Previously, you solved quadratics that look like this: 3x plus 5 whole squared minus 9 times 3x plus 5 plus 20 equals 0. And you learned that although you could do this a number of ways, it was most easily handled by considering a substitution. And what we talk about is letting u equal 3x plus 5. That means everywhere where you see a 3x plus 5, you put a u. So accordingly, we have this kind of an expression, which is u squared minus 9u plus 20 equals 0. It is much tamer, and it will factor if you want to solve this, and you will get u is 4 or u is 5. But then, we really weren't finished because the problem asks us to solve for x, so we have to take 3x plus 5 and set it equal to each value of u and solve for x, and at the end we get x is equal to minus 1/3 and x equal to 0. This really is a great analogy. So previously you could solve problems that look like this one, this one, this one, and this one. They were pretty straightforward. You found the antiderivative and you added c to the answer. The ones down here look much more formidable, and those are going to be the ones that we're going to talk about solving in this video. Let's begin with this first one. So what we're going to do is we're going to define something to be u, and we take u to be 6x cubed plus 5. So that allows us to make a substitution here. But also we have a dx. And the way we get at dx is this way. We compute du. That is the differential of u. Remember, we studied this before. So this is du is equal to, it's going to be the derivative of this times dx. And the derivative of this is going to be 18x squared dx. So u equals this, and then consequently du is equal to this. And since I have dx over here, I'm going to solve for dx, and I get it as du over 18x squared. Now you see what happens is then I have du over 18x squared, so the 18x squared here in the numerator cancels with the 18x squared in the denominator, and I sometimes call this magic happens. That means you've made a good substitution. And when I do all of that substitution, I end up with the indefinite integral of u to the 1/4 du. And that's an easy integral. I add 1 to the exponent and divide by the new exponent. That's going to be 4/5 u to the 5/4 plus c, which is what I've written right here. But then I have to reverse the substitution because u was this, so I change out u for 6x cubed plus 5, put it in here, and here is the answer to the problem. And this is called integration by substitution. A lot of times people will call this u substitution because we're letting u is equal to g of x. And if u is equal to g of x, then du is equal to g prime of x dx, and we can solve the problem this way. And some books refer to this as running the chain rule backwards. That's not exactly right, but it also shows a little bit of insight as well. Let's do 4 more examples. I encourage you to try these yourself before we look at the solutions, just to practice and get some neurons connected as you go. So pause now, and we'll see how you did. Let's work through these. So here, we're going to be letting, and here was the problem that we're trying to do down here. So we're going to let u equal w minus ln of w. Now if that is what u is, then du is going to be the derivative of w is 1, and the derivative of the ln of w is 1 over w, so this du is equal to 1 minus 1 over w, and then that is dw. And if I solve for dw again, I get du over 1 minus 1 over w. So when I do that substitution, you see magic happens because this cancels from the numerator and in the denominator. And so I wind up having the indefinite integral of the cosine of u du. That is going to be the sine u plus c. And then I reverse the substitution with what u is, and I have this answer. The next problem, and this was the problem that we were trying to do right here, we're going to let u be 4y squared minus y. Then computing du, I get du is equal to 8y minus 1 dy, and I can solve for dy, and I get 8y minus 1 in the denominator and du in the numerator. Now when I plug that in, this function of y will cancel with that function of y, and magic happened again. Now I can jerk the 3 through the indefinite integral, so I have this, and then this is going to be 3, the integral of e to the u du. The indefinite integral is just e to the u plus c. You might say I should have 3 times c, but 3 times c is the same thing as c. We treat the constants casually in this environment, and then we reverse our substitution because we let u be this, and we plug it back in, and now we have the answer to the problem. It is that. The next one, this was the problem that we were confronted with. We let u equal 3 minus 10x cubed. That means that du is going to be, now notice that there does end up being a negative 30x squared dx here. And so we have to keep that negative, but we solve for dx and we get this expression. So now what we're going to do is we're going to do the substitution. And so what happens is, again, the x squared is going to cancel in the numerator and denominator, but we do have this constant of minus 1 over 30, which we're going to pull through the integral. So immediately after doing the substitution, we have the indefinite integral of u to the 4th. This is minus 1 over 30 and du. Well, the antiderivative of u to the 4th du is going to be u to the 5 over 5, and I pull the minus 130 out, 1 over 30 out in front, and I get this as an answer. And again, I could have called this a different c, but any c will work, and so this is the answer to this problem. I think this is a next example is the one right here. We're going to let u equal 1 minus 4x squared. That means that du is going to be, again, another negative. It is minus 8x dx. And if we solve for the dx, we have this as du over minus 8x. So when I do the substitution again, magic happens because the x cancels, and I can pull the constant, the minus 1 over 8, out. So when I do that substitution, I get minus 1 over 8, and this is the indefinite integral of u to the minus 1/2 du. I add 1 to the exponent and divide by the new exponent. And so that means I'm going to have 1/2 divided by 1/2, which ends up making, when you do the calculation, is minus 1/4 u to the 1/2 plus c. And then I reverse the substitution that I had because my answer has to be in terms of x. Let's move on to a second example. Here are 3 problems. I'd like you to give them a go. This, of course, requires you to know the trigonometric integrals backwards and forwards. So pause and let's see how you did. Let's see how you did. Here was the first problem that we were confronted with. So what I'm going to do is I'm going to let u be 2 minus cosine of 1 minus x. Then du is equal to, now the antiderivative of the cosine is the negative sign, but I have a negative here already, and then by the chain rule I have another negative here, so there are 3 negatives involved in this. So when I take du, you should get minus sine 1 minus x dx. I solve for dx, and I have that du is, or dx rather, is du over minus sine 1 minus x. Now, the sine of 1 minus x then is in the numerator, and the denominator is going to cancel, but there is going to be a leftover minus sign, and so we have minus the integral of u to the fourth du. That's going to be add 1 to the exponent, divide by the new exponent. This is minus 1 over 5 u to the fifth plus c, and then I reverse my substitution, and I get that this is the answer to that problem. Here's the problem we were confronted with in this one. So we're going to let u is equal to sine of 3x. That means that du is equal to 3 because of the chain rule, cosine 3z dz. And if I solve for dz, because dz was in the integral to start with, I get du over 3 cosine of 3z. And again, magic happens. The cosines cancel. So I have, now I still have this 1/3. So I have it, pull it through the integral. I have 1/3 the antiderivative of the indefinite integral of u to the 10th. So I add 1 to the exponent, divide by the new exponent. That is u to the 11th over 11. I multiply by 1/3, and this is the final answer to that problem. This example, here's the one that we were going to do. So here's the problem as it will work. We will let u be 3 minus tangent of 4t. Then du is equal to, now the derivative of the tangent is the secant squared, and we have to use the chain rule. That's where the 4 comes from, and the minus comes from the minus sitting here. So du is equal to minus 4 secant squared 4t dt, and if I solve for dt, I get it as du over minus 4 secant squared of 4t. So when I do that substitution, I can pull the constant, the minus 1 over 4, through the indefinite integral, and I'm integrating now u cubed du. Add 1 to the exponent, divide by the new exponent, and what I will get is minus 1 over 16 u to the fourth plus c, and when I back substitute for what we had for u, or in terms of t, I get this as my solution. That's the end of part 1. Part 2 should be waiting.